Okay, in this podcast we're going to be looking at calculating probabilities given a probability density function that represents a continuous random variable. So just say we're asked to find the probability that the continuous random variable x lies between a and b. We carry out the integration from a to b of f of x dx, where f of x is the function that defines the probability density, or the probability density function. Now before we go on, I'll just point out that if we're asked to calculate the probability that a is strictly less than or equal to x and x is less than b, or any of these other options, and the top one, we just carry out the same integration for all of those. So no matter which question you're asked, depending on what the inequality is in these, you carry out the same integration there. So our example is going to be the continuous random variable x has the probability density function f given by that hybrid function. Okay, and we're going to find the probability that x is less than or equal to 0.5. So we're going to use one of these integrations here. Now, go over the page. So what I've done here is I've just sketched what the function looks like. Okay, so for x between 0 and -1, it's just equal to 0.2, but for x between 0 and +1, it's given by this function, 0.2 plus 1.2x. Okay, so we want to consider these things. Is 0 for, the function is 0 for x less than -1 and greater than 1, which is these regions. So we only need to integrate for x less than 0.5. We have to integrate two sections and add these together. The sections are from -1 to 0 and from 0 to 0.5, which is going to be about up here. So that's all we need to integrate. Carry out those integrations. We end up with that. Simplify that. Gives us the next step. Simplifying again, we find out that the probability that x is less than or equal to 0.5 is 0.45. Okay. The next thing we're going to look at is finding this. So this is a conditional probability question. Finding probability that x is greater than 0.5 given that x is greater than 0.1. Okay, and that's what I've just highlighted there. Now the general rule for conditional probability is this one. Okay, and we're given a to be x greater than 0.5 and b to be x greater than 0.1. Now, if you think about it, x greater than 0.1 and x greater than 0.5, that overlaps when x is just greater than 0.5. So this just becomes simplified to this probability. Now, similar to the last step, we need to find out over which regions we need to integrate. We know that the function, the probability density function is 0 for x greater than 1, so we just need to integrate between 0.5 and 1 of the function that's defined in that interval. 0.2 is less than 0, 0.2 plus 1.2x is greater than 0. So I carry out that integration. There's some working out. You can pause and check over if you like. You should do that really, just to make sure I haven't made any mistakes. And we find that the probability of x greater than 0.5 is 0.55. So that's taking care of this bit here. Now we need to take care of the bottom bit there, probability of B. Now the probability of B is given by probability of x greater than 0.1, which is another integral, this one from 0.1 to 1. And again, the function that's defined over that interval is that one. So let's go and carry out that integration. And what we find is we have to simplify that, which is the same as that. We find out that that's equal to 0.774. So now using my rule, all I do is divide 0.55 by 0.774 and I get 0.771. And that's a conditional probability question. With continuous random variables. And there'll be some questions on the Google presentation that you can have a crack at, using that as your example.